Hi everybody, this is Mr. Bishop. I'd like to welcome you all back to our screencast to begin Chapter 4, Populations, and our main ideas. We've got a 15-minute timer going, so let's get right into it and see how far we get. Population. Population is made up of individuals that live in the same area. Individuals of the same species that live in the same area. So we've talked about this earlier in our ecosystems chapter, and this is just a reminder of that definition. Now we're going to get a little bit more specific as to two different types of populations. Our first type of population is an open population. An open population is when a population can increase or decrease in size as individuals enter or leave the population. So an open population is a population that animals can migrate or emigrate from. Our next population is a closed population. Closed population exists only in laboratories, such as yeast raised in test tubes or bacteria raised in petri dishes. So immigration and emigration are not possible in a closed population. Their entire world, so to speak, only exists inside that petri dish. Rate of population change. So the size of a population changes through time. The population change can be expressed as a rate of change, and the amount of change divided by the amount of time expresses a rate. So if we had a population of 100 this year and 80 next year, that we would have lost 20 individuals from our population in over a 1 year time. So that would be negative 20, minus 20 per year. Here we have a population pyramid for a developing country, and this is a pretty ideal population distribution. So down here at the bottom of our pyramid, we have our pre-production population, pre-reproductive population, right there. So those are our individuals who are the ages 0 to 4 up to about the age of 19. So those are individuals in the population who are not reproducing. Then in our middle section of the population, from about the ages of 20 to 50, we have the reproductive portion of a population for a developing country. And then, of course, from 50 to 80, we have the post-reproductive population. Now, of course, there are exceptions to all of these populations, but for the most part, it is pretty consistent that from 0 to 19, most individuals are not reproducing. From 20 to 50 is when people are typically either getting married or starting families, and beyond 50 to 80, most people are getting grandchildren at that point because their children are entering the reproductive stage of their life. Population pyramid for a developed country. So things are a little bit different in a developed country. So we still have our three sections of the population: the pre-reproductive, the reproductive, in the post-reproductive. But as you can see, compared to our previous slide, I'll just switch back for a quick second. So we've got a large portion of our population in the pre-reproductive stage ages, about an average amount in our reproductive stage, and then very little as we get into our older years in a developing country. In a developed country, the quality of life is a little bit better, healthcare's better, food sources are more abundant. We're able to live longer and be healthier into our 80s and 90s and sometimes even hundreds. So our population is much more evenly distributed. There's about, of course there are some variations, but if you look at percentage in age group down here, where we've got, the difference in percentage between our 15 to 18 and our 45 and 49 is somewhere between -4 and -2%. So probably about 3% difference for our male portion of the population. And then over here on our female portion of the population, it is pretty similar. So we can see up here that women tend to live a little bit longer than men, and that is reflected in the population distribution at the top. But there's very little difference compared to our developing country, where we had in our individual males or females in their 80s and the females and males in their teens, you can see that there's close to 6 to 7% difference in population distribution. So here they are all side by side. So we can see growth rate predict age and grouping trends. So we have the population of Kenya, the United States, and Italy. So Italy's a much older country than the United States, and Kenya is a developing nation. So we can see that Kenya follows that population trend of a developing nation where they're going through rapid growth currently, and as the individuals who are ages 0 to 9 and 14 age, they will join the population group up here, and there will be a much larger population in the reproductive ages, whereas in the United States we have, again, a more even distribution in our age groups up until about age 70. That's when the population starts to decrease. And then in Italy, we actually even have more people in their 20s and 30s than we do individuals who were between the ages of 0 and 10. So as you can see, this is a little bit of an older graph, as most of you were born in the 2000s. This is people who were born in 1994. So this is just a comparison to see that in Kenya, in a developing country, we have rapid growth. The United States, we have slow growth, and in Italy, there's actually a decreasing or zero growth population. So, you decide. France is an example of, we can see that we have a population distribution pretty equal, and still more at the bottom than up near the top. So France, I would say that we would be able to say is an example of a developed country with a slow growth rate. Whereas India, we can kind of see that pyramid, that steep pyramid, where we've got a lot of people in 0 to 20, the pre-reproductive ages, and a lot less in their post-reproductive ages, and then an average population in the reproductive stage. So India is an example of a developing country with a rapid growth rate. Here is a map of the population density of the United States. So the areas of red are areas that have very dense populations. So you can see over here, it says New York, but this state right here is New Jersey, where I grew up. And fun fact, New Jersey is the most densely populated state in the United States. So we can see where our greatest portions of the populations are. Obviously, Los Angeles, San Diego, San Francisco, Seattle, Chicago, Washington, D.C., New York, Boston are major cities, have extremely dense populations. Miami, New Orleans, Dallas, whereas we can see, Arizona, not a big state, but not many people per square mile. We can see out here Nebraska, Kansas, Missouri, the Midwest area. We don't have as dense a population as we do in our Northeast and our Southwest and other portions of the country. Causes for population change. So population size is determined by two rates that increase population and two rates that lower population: natality, immigration, mortality, and emigration. So natality is people being born. Immigration is people entering a country. Mortality is death. And emigration is leaving an area or a country, if we're talking about people. Increase in population size. So natality, birth rate. Natality equals birth rate. So equals. Natality equals birth rate. Immigration is equal to a movement into a population. Conversely, decrease in population size, emigration is equal to movement of individuals out of a population, and mortality is equal to the death rate of a population. Factors that affect future population growth. So here is a diagram, graphic organizer. So we have our central ideal population. We have our positive axes for natality and immigration. And we have our negative axes for mortality and emigration. Environments limit population. The environment limits the population size. So population size may change based on environmental resources. The environment can be divided into two parts: the biotic environment and the abiotic environment. So those are both terms we should be familiar with. So our biotic environment is the living parts of our environment, and the abiotic environment is the non-living parts of our environment. So living and non-living parts of the environment affect population size. And this is a good time to stop, and we will pick up with our next presentation.